thank you all for coming with 4 hours notice. So I appreciate that there are some people to attend. All right, this was a talk actually I gave last week in front of Canil. So as I'll go through it, you might notice like some of it is geared towards people with a more transdisciplinary audience and trying to engage lawyers in some of these issues. Basically, it started when I went to the Merriam-Webster website, and I redid this experiment recently, and so I was presented with this screen, and I diligently clicked reject all, and go down on their website, and I noticed that there's an opportunity to learn a new word every day. And I like learning. So I looked around. This was all the context involved in enrolling in this, and I'd already clicked reject all. So I sent them my email, and I looked at the network traffic, and I could see my email being sent to merriam-webster.com in the context of enrolling in their word of the day. But I also noticed something strange, this random looking string being sent to Amazon ad systems, an ad network, sending something they call a record of type email in the context of a hashed records. And indeed, this random looking string is not random at all. It is the SHA-256 hash of my email address being sent to an ad network. And okay, that's a bit odd, but I continue looking at the website and visiting other things, and then I see the SHA-256 hash of my email being sent to AdThrive, as well as the SHA-1 hash being sent alongside, and the articles that I'm looking at, and so forth. So AdThrive, or this made me want to understand why this was being collected, and so their privacy policy said that they will collect and use certain data for advertising purposes, and AdThrive is owned by Raptive, and they suggested that I visit Raptive and understand what that means, and they described it as not typically containing any information that would personally identify me. So I guess the email hash was just an accident that it ended up there, because it shouldn't normally identify me. But the Merriam-Webster privacy policy even went further. They said that they take user-level information and anonymize it through hashing. They're a dictionary, so they're in a position to understand what words mean. And they further provided an example of what a hashed email might look like. Challenge accepted. So I sat thinking, like, how can I brute force this and take a dictionary of words and figure out what corresponds to this hash? But I had a moment of inspiration, and I swear this is true. I thought, what would I use as an email address if I needed an example email address? And I tried it, and I guessed it correctly on the first try, that there was example@gmail.com, produced the hash in their privacy policy. So it turns out that these email hashes are quite a rampant thing in the ad tech world. Here you can see it's a digital identifier. Hashing an email is a way to maintain privacy. It allows you to track and understand consumer behavior while maintaining privacy. Benefits of a hashed email address: they cannot be decrypted. What's a hashed email address? In a post-third-party cookie world, they will be the future of marketing because we need alternative tactics. This sort of evoking of a military metaphor that all these privacy controls are ruining our good time, and we need to find new ways to undermine them to violate people's privacy. You can imagine a hashed email as a passport in the digital world. It's anonymous, secure, protecting their privacy. A hashed email is extremely difficult to decode without the special key used for encryption. You can't reverse the hash to retrieve the original email address. What is an email hash? This is from about a month ago. A privacy-safe, completely pseudonymous identifier. And an earlier version of that page described it as being encrypted, completely anonymous, and cannot be reversed. And finally, here we have an example where you can, sitting on a gold mine of information, because you can track all these things about your consumers using their email hash, but you can't trace it back to the customer's data. It's privacy safe. A digital passport that traces everything you do, but it's private. Now, you can look at these claims and think that these are clearly people who don't understand what hashing is, and they're making these claims because they don't know any better. But the thing is, it's not just random blog posts, and in this case, $1 billion credit reporting agency. It's companies like Facebook. Hashing is a type of cryptographic security method. The process cannot be reversed. Facebook says you have to hash the email, you have to hash the phone, you have to hash gender. Facebook believes in 2 genders, the letter M and the letter F. But it's hashed, and that way it's totally anonymous. There is no way to figure out which is which. hash a year, hash a birth month, hash a birthday. Now it's completely anonymous. It's no longer personal information. Google, hashed and sent to Google in its hash form. This is privacy safe with hashing of first-party customer data. Google suggests using SHA-256, the industry standard for one-way hashing. Snapchat, how do I hash identifiers? For example, phone numbers. Remove the hyphens and the spaces. That way you're going to get the same hash as other people, allowing you to match these anonymous identifiers to specific individuals. TikTok, in their pixel, it will automatically identify form fields and hash and collect phone numbers and emails as you enter them in. Pinterest, for privacy reasons, we hash your email. It turns it into a short text string that cannot be read by humans. We just see a black square. You can't perceive what it turns into because it's hashed. Adobe, hashing is a one-way function. There's no way to reverse the hashing function. And finally, Oracle, hashing is a form of encryption. Anonymously trade email, mail, and phone number information without sending any personal information. Absolutely incredible. And these claims are being made in courts by experts to judges to support this exact same thing, that you can take an email, run it through a hash function, and now it's an anonymized string. That, in this case, Disney was sending hashes to Adobe, but there's no way Adobe could possibly reverse engineer these hashes from a small domain. However, when it suits their purposes, they're happy to tell the truth about it. Here's Facebook saying, Brand Total's claim that it anonymized user data was misleading because it just used a hash function. You can't just hash something and make it anonymous. That would be ridiculous. So they're willing to make the opposite claims as well in court that they're making in their published information to consumers. And so at this point, you might think at the totality of these statements and just conclude that this is bullshit. The things that they're saying is bullshit. But the thing is, this does not comport with the normative definition, the Frankfurtian definition of bullshit, which is characterized by an indifference to the truth, that you're making statements and they may land in the truth, they may land as a lie, but it doesn't matter. It doesn't matter where it ends up. Your statements are just being made without concern for the truth. However, it very much matters that the statements being made are not true. Because if it were true that it was anonymous, it wouldn't be interesting to collect, and they wouldn't be collecting it. The only reason they're hashing emails and collecting it is because it's not anonymous, and their business model relies on that, which means that it's not bullshit, these are lies. These are lies, platonic lies, noble lies, as in the lies that the ruling class tells the people in order to maintain social control. Lies that are being told to regulators, lies that are being told to courts, lies that are being told to consumers, lies, lies, lies. I want to look at a few more examples of some network traffic. These were experiments I did just a few weeks ago in France. Excuse all the French on it. This was also for the Canil. So I went to the Sephora website. In this case, it was well-behaved if I rejected the cookies, so I ended up accepting all the cookies, but I looked at the privacy policy, and it said that these cookies don't identify users, they identify browsers and devices. Another lie. You know, we're only recognizing the device, not the pocket of the person the device is always in. They have nothing to do with your device at all. And Sephora had the opportunity to enroll in a newsletter, so I looked at their little disclosure, and it was basically, we'll use your email to send you stuff, and here are your rights, and okay, it seemed all reasonable. So I entered in my email into their website. Again, I looked at the network traffic. I could see my email being sent to the first-party domain in the context of enrolling, but at the same time, Pinterest received the hash of my email, and TikTok received the hash of my email, and Snapchat received the hash of my email, and Facebook received the hash of my email, and the hash of my first name, and the hash of my last name. And all of this was being transmitted prior to the transmission to the first party, because these tracking pixels have embedded themselves in the website's form. So as you're typing things in, they're aware of what you're typing in. When you submit it, their scripts trigger first. They recognize that this is an email address. They hash it and send it to their services. So this is not just a pixel walking around with you as you travel the web. This is someone looking over your shoulder as you're typing things into the form fields. I went to Le Point to get some right-wing news from this company, and I couldn't reject all cookies because I'd have to give them my credit card, and that was a non-starter, so I accepted the cookies. But I was relieved because they said that they used limited data for advertising, limited data. And so I tried to read an article, but I immediately had to present my email in order to continue. So I entered in my name and my email address and enrolled in their news site, and immediately see to an ad network, bidder.criteo.com, what I'm looking at and the hash of my email. You know, limited information. I went to use the Carrefour app. Again, here I hit refuse all, but it wasn't doing anything particularly bad. I created a little account, and then I started playing around with some of the things I could turn on to see what did what. And in this case, there was Firebase. Firebase said that it harvests and uses statistical data. So I turned that on to see what statistical data actually means. I searched for something that had a privacy-sensitive context. I put a heart next to one of the items. I look at the network traffic, and I see this happening to the first party, the sort of implementation of that feature called add to wish list. This is now the item ID, some identifier for that particular item, along with its name underneath. And at the same time, a different app on my phone, Google Services Framework, a pre-installed super app from Google that comes on an Android device, was sending to app-measurement.com, which is Google Analytics, all of that same information, but also included the hash of my email address. You know, statistical information. And if I searched for something, whatever I typed in this case, delicious homemade potato crunch cereal, I see exactly that. What I typed in being sent along with the hash of my email address to Google Analytics if I turned on that Firebase tracker. So that takes us to the first lie that I want to cover, which is that hashed emails are irreversible. I refute it thus. It is manifestly not irreversible. But in order to understand exactly why, it's useful to consider password storage. Because for password storage, we do use hash functions, and we use them in a way to attempt to achieve this kind of one-way irreversible property, but it comes with a lot of caveats in order to get that right. So the basic idea, you enter your username and password, that gets sent to the server computes the hash of the password, looks up what it's storing, checks if they're equal. If it is, you're logged in. Now, no matter what hash function you use, no matter how effective it is, the following attack will work. You guess a username and their password, and you're right, and you get logged in. Because hash functions cannot, and they're not designed to do anything to do that. It doesn't matter how this is being stored. This attack will always work. If you guess the right answer, you will be able to log into the system, right? And if you just keep guessing, eventually you will guess the right answer. So the defense that we have is to effectively slow down the time before saying you entered the wrong password. Or we say, this is too many attempts, we're going to shut down this account for a little while. It poses a natural speed limit. You can't make unlimited guesses. You have a certain rate that you can make these guesses. The only reason this works is because we don't share this information. We don't publish password files. We don't make them available. We don't trade them with other companies and call it anonymous. That's the only reason that this slowing down speed limit works. Once the attacker has the password file, they are only limited by the rate that they can make these guesses. So the faster they can make these guesses, the sooner they'll break the password. The way of visualizing this, we can measure passwords in bits of entropy. So this corresponds to the logarithm of how many possible passwords there are, how many other similar passwords of a certain type you'd have to go through before you've tried all of the ones in that category. So for instance, at 1 bit, we have gender, the letter M or the letter F, birthday, 4-digit number, and so on. Different formats of passwords and where they fit in on this scale. The idea of having password complexity requirements like capital letters and punctuation is only to push it down further down on this scale because we assume that eventually the password file will get compromised. That starts the clock for when the attacker can break your password by just guessing them all. And in the time between compromise of that file and the attacker guessing it, the user hopefully is aware and they change their password. Another thing that doesn't happen with your email. When ad tech shares your email with other companies, you don't get a new email address because it's been compromised. Now, on my laptop that I'm presenting right now, this is the rate that I can perform SHA-256 hashes. Now, we don't use SHA-256 for password storage, but we do for email hashing in this context. So I'm using the benchmarks that I have for that, and you can see that in 1 second, I can explore 27 bits space on my laptop, which means all passwords higher than that I can do effectively in a fraction of a second. What about emails? So here's a common first name, common last name, and different types of email formats that you can think of, right? And how long it now takes to perform this brute force search of the entire space. And you might be looking at this and thinking like, oh, where does my email actually fit in? What is the sort of entropy of my email on this scale? And if you are, you might be thinking that you've never thought of that before, which is another difference. We're not told to make our emails hard to guess. We're not told to make them complicated. We're not trying to have them be unguessable or survive a brute force attack on the hash function in order to obtain privacy. Yeah? Yes. So if someone if they already knew your email, they could just hash that and then they can see, in fact, and I'll be getting to that in a second. But even if you just had the hash and you wanted to figure out whose email it was, then in a second you can cover 2 letters, a name and a number at gmail.com and all possible permutations of that. And I will point out that this is all assuming gmail.com as an example. If you wanted to do 32 different domains, you would have to add 5 bits. So everything shifts down by 5 on this scale. So still quite possible to mount these attacks and determine what people's emails are from the hash. So when passwords were first academically introduced in 1979, this idea of a brute force search was known to the authors, and this was their threat model, an attacker who had access to one of these. And they proposed a technique called salting, which we still use today, slightly different because they weren't using hash functions, but the idea remains the same and we use it for the same reason, which is that when we are hashing a password, we include some randomness attached to it, and we hash the randomness and the password together. This means that 2 people with the same password will have different hashes, so an attacker who steals this file doesn't automatically see what was the most common occurring password under the assumption that might be easier to guess. But it also stops a dictionary attack. Now, a dictionary attack is where you pre-compute for an entire domain all possible things you would want to reverse, and you order them by the hash so you can retrieve the pre-image of the hash function based on the output of the hash function. You're effectively just computing that function in its entirety and storing the result. Then when you steal the password file, you can just immediately do a database join. You don't have to do a brute force attack for each password. Now, salting addresses this problem not because it prevents dictionaries from being built, but rather that each dictionary is now salt specific. So depending on what the specific salt is, you'll have a completely different dictionary, and there's so many possible salts, cryptographically large, it's just infeasible to have all these dictionaries ahead of time. And you can build it, but you wouldn't know what the salt is anyways until you compromise the password file, and then effectively you're doing a brute force attack. To give you an idea of where dictionaries fit in on the scale, at 1.5 terabytes, you can have a dictionary covering a 36-bit domain, which is a large number of types of possible email addresses. Now, of course, 6 petabytes is rather unreasonable amount of storage, but 1.5 terabytes, I could probably find a hard drive in town and pay without any issue at all. It's available certainly for consumers. However, there's another approach, was from 1980 from Martin Hellman, and he proposed a time memory trade-off. So imagine you have your word and you have its corresponding hash, and then you create the entire domain of all the words and all of their corresponding hashes. His idea was that you create some random reverse function that takes an arbitrary hash and uses it to pick some element from this space. The idea is that this space is too big to fit in a dictionary, but what you can do instead is now perform random walks in this space, going from a word to its hash, back to a word to its hash, back to another word to its hash, and so on, and then follow this walk. At the end, the only thing you actually store is the end of the walk pointing back to the start of the walk. You can always walk it forwards, and then wherever you happen to land on this walk, you can walk it to the end, rewind to the start, walk it forwards again, and effectively this one piece of information is storing the reverses for all of the hashes you would have encountered on your walk. Now, There's a problem with collisions, which is because of the hash functions are deterministic, once you collide on an element in the reverse function, the rest of your walk is going to be the same. And if you are trying to comprehensively cover an entire domain, you're going to have collisions all the time. The solution, known as rainbow tables, was to use a different reverse function for every single step along the walk. This has the cost of a quadratic lookup time, because now you don't know where you started on your walk. If you're at a particular element, are you 1 from the end, 2 from the end, 3 from the end? So you have to try all possible positions, making the trade-off quadratic. Effectively, 10 bits of storage reduction turns into 20 bits of work. Well, 20 bits of work is still fractions of a second on my computer, and 10 bits of storage turns petabytes into terabytes. It drops a full letter in that alphabet of megabytes, gigabytes, terabytes, and so on. So using a rainbow table of size 12 bits, for example, of chain length of 12 bits, now we can cover a 48-bit space with, again, just 1.5 terabytes. So I built a tool for doing this. I called it Rainbow Warrior, and I then found that there was a beer in the south of France called Rainbow Warrior as well, which I was delighted to see. And the main thing that I wanted to do was make it very easy for me to, with a markdown-like language, describe different types of formats, then build rainbow tables for that specific format. For passwords, it's generally easy. You just, every letter, number, these sorts of things are valid passwords. Emails tend to be much longer, but much more prescribed. It's name.name@gmail.com. And so with this, I could build these reverse functions and then make a rainbow table specifically for all emails that match this sort of format. And then using that, I created a bunch of different formats to try to see which would be the most effective rainbow tables, which would help me reverse the most hashes as a result. I effectively wanted to manifestly prove that these are easy, readily done attacks. Because while everyone knows that, of course, you can reverse email hashes, it's still being said in courts because a common person can't do it, effectively, is an argument being made. So in order to actually reverse some email hashes, I also needed to get some hashed emails. So we went to DataRaid, a search engine for people's information, and we searched for HEM, which is the cool way of saying hashed email. And you can see at the top left, a bunch of these data brokers were giving out free samples. And incredibly, we managed to get millions of rows of data with no questions asked, just gave it to us as a teaser, when trying to get us to subscribe for $10,000 a month for billions of rows of people's data. And you can see I've hashed the names of the brokers to preserve their privacy here. And all of this data came with other associated personal information as well. And so from that, we sampled some of these hashed emails from these different brokers. We've been able to recover with just rainbow tables more than 50%. So I can say that more often than not, I can reverse an email hash using the rainbow tables I built, just to give you a few examples of the types of formats and their prevalence. So the rainbow table of name, letter, name had a match rate of 17%, then 12% for last name, common first name, 2% had word followed by a number in the data that we had been given. Some interesting domains popped up. The data brokers were selling army.mil and some mail.house.gov. There were some Proton mail users. There was a couple that were clear opt-outs, like opt-out of spam at mailinator.com, things like that. Some GDPR-relevant ones, some banking-related ones. So a lot of interesting domains in the data set. Now, there's another way of seeing whether or not, or compiling a list of email hashes, which is if you have a list of emails, you can just hash that list. Troy Hunt operates the website Have I Been Pwned, where he tracks data breaches that have occurred. And you can enter your email and see if your password's been on a data breach. And necessarily, he would then have a lot of people's emails. So we asked him, hey, we have this list of hashes, can you tell us the match rate? And he said, well, the way the database is set up, it would be a really expensive query and it wouldn't be possible, but sorry. But then a few days later, he wrote back 88%. He said he couldn't stop thinking about it and he had to know, so he made some changes and ran our query. He has 5.7 billion addresses in his data breach set, and there was an 88% match rate to our data broker data. So given the hashes to him, 88% are effectively can just look right up. We thought that was oddly high. What's the normal match rate? And he said that a normal user entering their email on his site and clicking send controlling for bots, controlling for APIs, has a match rate of 44%, half, which is an incredible difference versus the data broker data. And we've been passing around a few theories about this. I mean, one is that literally every user types their email, sees they've been on a breach, and then they type something random and to confirm that that one's not on a breach, testing the system. Troy doesn't think that's the case. It could be that one of the data brokers themselves was in a breach, but then he wouldn't have collected it because they wouldn't have had passwords. It could be that people who use his site are more privacy conscious and less likely to consent and therefore wouldn't have their data on data brokers. But as we saw with the examples at the start, you can click reject all and your hashed email is still being sent. So another theory is that data brokers' data somehow includes data breach data that just got in there somehow, despite the claims of consent that they make about it. I gave this talk on Monday at Saarbrücken, and the person in the audience actually is a member of a hash reversing hobbyist that uses GPUs for fun to just reverse hashes. And he said, hey, can we try your list? And I'm like, sure. Effectively, overnight, there was a 99% rate that they matched for the ones I had already matched. So I called this the easy set. Basically, instantly, effectively, they were able to do 99% just using brute force GPU attacks. And then the other set, the ones that I hadn't matched, they got to 90%, again, effectively overnight, and pointed out that there is a lot of bad data in there. There's a lot of malformed data. There was a lot of exclamation points in the email addresses. There was things that weren't even emails. There was a lot of domains that, like Lycos and Alta Vista. So it explains that maybe the 50% I was having trouble matching just wasn't actually good data, or I wasn't eventually going to ever match it anyhow. All right, the second lie, that hashed emails are anonymous. So here, the FTC has made an opinion. In 2012, they said, no, hashing doesn't make your data anonymous. And a couple months ago, they refined that and said, no, it still doesn't make your data anonymous. We had been sharing some of our results with the FTC, so we have a feeling that perhaps that might have been a reason why they felt the need to produce a blog post reminding everyone that you can't just hash data and make it anonymous. But let's look at why. So suppose here we have an anonymous identifier sitting alone, not harming anyone's privacy. And this would be somehow linked to an email address. So there's a person who has this email address. I have a double circle, kind of like a veronym, and then a single circle, an anonymous identifier. And these two things are linked. Not connected formally, but it's an association. They belong to the same person. The anonymous identifier might be a cookie that I have for some website. Now, a data collector using this anonymous identifier can collect it alongside attributes, things I bought, things I read, things I liked. And another data collector using a different anonymous identifier, but all still corresponding to the same user, might collect it with phone number or name or other things like that. Now, on its own, these two different data brokers can't really do much with their data. They've collected data about the same person, but they can't associate their anonymous identifier with the other one. But even in this case, it's already a lie to say that the data broker on the right is really using an anonymous identifier, because the name, of course, derives who I am. That indicates whatever notion of me you might want. To say that this is anonymous to this data broker is not the case, because as soon as you provide this anonymous identifier, they immediately know exactly who you are. So to them, it's not an anonymous identifier. And moreover, there's an increasing body of academic work showing that attributes about you make you unique in a crowd and can reveal who you are. So once you know enough about a particular person's interest, they are now unique in the world as per that interest. And if you just happen to know a little bit about that person, you can find them in that data set. This is what happened with the IMDb or the Netflix attack. Effectively, Netflix was publishing all of the films that users liked was just thumbs up or thumbs down, not like really reviewing it. And once you were seeing some particular user in all the videos they watched, they would be unique in that data set. If you happen to know that a particular user reviewed some films on IMDb with their real name, you could then find them in that data set and see all of the other things that they watched as well. Now, This is the case with these anonymous identifiers, but what about hashed emails? So here we have the email, it derives the hash, as we showed with lie 1, you can brute force back to get the email, but let's just pretend that the first lie holds, that really somehow this hashed email is irreversible, you can't get the email back for the hash. What happens still? Well, now this data collector is collecting with that, this data collector is collecting it with the same value, and now they have a common language. They can share their data and combine it to get a better understanding of the user. And in fact, this is exactly what the companies are describing that they do. You cannot reverse a hash, but you can match it when two people have the same email. Google maintains email addresses for Google accounts and the corresponding hash strings for all those email addresses. When you send Google a hash of an email, it looks up who that specific person is and adds that information into their dossier. Facebook uses hashed information, compares it to our own hashed information to accurately determine specific people. Right? They're describing a dictionary attack. What they are doing is a dictionary attack. They receive the hash of an email, they have a dictionary mapping hashes to dossiers or profiles about people, and then they immediately de-identify you, all while saying that this is an anonymous identifier that they use to identify you specifically. And this would still be the case even if it truly were anonymous, because as long as every data collector agrees to use the same thing, then they can combine and share their information. Using an email hash just makes that convenient, that they don't have to pick a different identifier to use. In fact, it's really telling that Adobe says that it should be hashed with SHA-256 without salting. They go out of their way to say don't salt, because someone who is reading that we're hashing for privacy might think, well, then of course we would have to salt. This is a best practice. Obviously, if you don't salt, you're going to have these dictionary attacks. But the whole point is the dictionary attack. That's what they're trying to do. And so to say don't salt is because they are mounting dictionary attacks on these anonymous identifiers to identify the specific person. Right? If you had a case where you salted the email hashes, now these two things are connected, but not officially, and so the two data collectors can no longer trade their information as a result, and we're back to the first case. Another example of why email hashes are not anonymous comes to us from Gravatar, which offers that your email address becomes your passport to the digital world. Now, I noticed Gravatar when I was searching my network traffic for the hashes of my emails being sent, and this is the hash of my email being sent to Gravatar, a company I never heard of, so I looked into them, and basically what they provide is a service to turn email hashes into identities. So you go to gravatar.com/emailhash.json, and you get back a dossier of information, mobile, phone, email, in this case, links to various accounts. Now, all of this is curated by the user of Gravatar. So this user elected to put all of this information into Gravatar, and it's indexed by the hash of their email address, corresponding to their account. Now, incredibly, despite the fact that Gravatar creates a service mapping hashes of emails to identities, in their own privacy policy, they say that de-identified data that can no longer reasonably identify you can be shared for ad campaigns, and such as the hash of your email address, even though they're the ones creating the service to turn, for all of its users, email hashes into identities. It gets even stranger. On Stack Overflow and the whole Stack Exchange network, you may have noticed, if you've ever used it, these icons that appear, these pictures of people that appear at the bottom. Now, the ones that are like fractal art like this come from Gravatar. In fact, they all come from Gravatar. But this particular example, this is, again, the hash of my email address. You can see D equals identicon. If you pass that in, it'll use the bits of randomness from your email hash to generate some fractal art, and then that wherever you use the same account, you'll have the same fractal art. But this is despite the fact that I don't have a Gravatar account. And the way Stack Overflow works is that whenever you load all those images, you get a web page with links to Gravatar of everyone's hashed email that is a user of Stack Overflow. So you go to Stack Overflow, you see all the pictures, even those without Gravatar accounts, the email that they use to register to Stack Overflow is sent to you, and then you use, or the hash of it is sent to you, and then you use that to retrieve those images from Gravatar. Effectively, you can de-identify all the users on Stack Overflow, despite their claim that only your username is public. It's your username and the hash of their email address is what's public. Now, interestingly, of the data collected from the data brokers, we randomly sampled and found that 2% of them had a Gravatar account, which aligns with how many users Gravatar says that they have. And on Stack Overflow, we randomly scraped some users, and we searched if they had a Gravatar account, and it was 45%, so much higher. So a few reasons for this discrepancy. One, Stack Overflow users may be more engaged with the web and have more accounts for more things, or in order to set the image on Stack Overflow, they had to create an account, and they were fine with that. They did that process. However, there's something interesting from Gravatar's own frequently asked questions, which is, why do I have a Gravatar account if I don't remember creating one? And I would argue that you have a problem with consent if this is a frequently asked question on your website. Now, this is known, of course, we all know that you can't just hash things and make it anonymous. In 2018, some scholarship from INRIA had a document about this, and they used Gravatar as a case study where they referred to a 2013 study where members of a far-right political forum were de-identified because they were using Gravatar. And in fact, 15 years ago on Metastack Exchange, someone asked the question, hey, this Gravatar thing is really bogus, it's not secure, you can easily reverse these email hashes. So it's just been known for this long, and that's presumably why they never got back to me half a year ago when I pointed out that they can de-identify all the users on their website. All right, lie number 3, that advertising IDs are anonymous. Advertising IDs are these numbers tied to your mobile device. This is an example on Android, just some random number that is tied to your device. As Google describes it, in a court filing, it's synonymous, device-specific string of characters that is neither tied to a user's identity nor used to personally identify a user. Users may reset their ad ID at any time. Or, as described by Full Contact, mobile ad IDs are tied to individual mobile devices, which makes them precise in identifying specific people. So consider the advertising ID. It's tied to your device. There's you and your email totally separate, other side of the screen. What if a data collector collected both the advertising ID and the email together? Now you've linked these two notions of a device identifier and a personal identifier. And then, if you take advantage of this opportunity to reset your advertising ID and obtain a new one, well, eventually that data collector will collect your email with that. And if you buy a new phone, you're probably not going to get a new email address and tell all of your contacts to use this one now. That phone will have an ad ID, and eventually it'll get linked to your email as well. Right? So you're able to do this sort of cookie syncing, this temporal cookie syncing across resets of the advertising ID, across buying new devices, all because the email remains the same. And this state of affairs works the same if you use the hash of the email or any deterministic function computed on the email. It's no longer as identifying as an email address, although with lie 1, we can then get the email address from it. But it's still the same state of affairs. You can link across resets that you might do to obtain privacy, and it's circumvented by linking it to an identifier that hadn't changed. So effectively, the advertising ID has become this anonymous identifier that everyone just agrees to use so that they can share their data readily. And then, by linking it to the hash of an email address, it can persist across resets or partial views of information, making sure that the user doesn't actually achieve their privacy goals by resetting their advertising ID. Now, what I described is a hypothetical attack. Does it actually happen? Well, in this case, I offer evidence from, again, the Carrefour app. I turned on Airship in the context of personalization, not in the context of ads. This was to provide me with push notifications in the app. So I turned on Airship for push notifications, and I see my first name, my email address, my last name, and my advertising ID, among other things, going to Airship. So yes, it is happening that the mobile ad IDs are being linked to personal information by these data collectors, despite Google's terms of service prohibiting that. That for analytics use, the advertising identifier may not be connected to personally identifying information. Full stop. For advertising use, it is allowed with explicit consent of the user. And yet, it is still the case that my information is being linked and sent to Airship despite being a violation of their service. And in fact, these data brokers that are selling the data have billions of rows of privacy-compliant, highly accurate, personally identifying information, mobile ad IDs, 2 identities. These are the things that are being sold by these brokers. In fact, all of the data that we got from them was hash of the email and their advertising ID. Now, this is fake data, but the real data looked exactly like this. So, what about another attack? Suppose you have the advertising ID, and then you reset it to get a new one. What if a data collector thought, hey, why don't I just collect both? Because this user is trying to take advantage of this privacy feature that Google claims exists. Why don't I just collect both the old one and the new one to completely undermine their attempt at privacy? Well, dev2dev does exactly this. So in this request, we have device ID followed by a base64 encoding of my current advertising ID, previous device ID, base64 encoding of the previous one before the reset, user ID and previous user ID, the same 2 values, because of course device IDs are user IDs. Device encoding, it's base64 encoded. So if you reset your advertising ID, dev2dev says, well, that's too bad for you if you were thinking you might get some privacy out of that, because we just don't care and we'll just collect both. And their own website documentation states this directly. If an advertising ID is changed, switched on or off, SDK notifies server about ID replacement. The thing is, they're not a fly-by-night operation. They got bought by $1 billion company who presumably triggered the under mergers and acquisitions clause of privacy policies that allows sharing of information that had been collected for purposes that weren't disclosed originally. Meaning that all of the historical advertising ID resets that they had collected in all the apps that they were in now is available, presumably, to this $1 billion company that hadn't been collecting them. And in fact, more than 2.5 years ago, I had noticed dev2dev because they were also exploiting a side channel in the operating system, getting information that they shouldn't have been able to get, and noticed that previous equals new old advertising ID, UID equals current advertising ID. I told Google about the side channel exploitation and also mentioned, hey, also this is happening. This is a clear violation of your terms. They said, thank you, never heard back. They're still doing it 2.5 years later. They got bought by $1 billion company. Which takes us to the final lie, that they were all collected with consent. All the data brokers that gave us data said it was privacy compliant, collected with consent of the users, and to that I ask, consent like when you say reject all and it just does it anyways? Consent like when you're told it's statistical information? Consent like you subscribe to a newsletter and that allows them to extend consent to wherever readers are paying attention as they browse the web? Consent like when you're told you can reset your advertising ID, but someone can just collect both and no one seems to stop it? Consent like the advertising identifier may only be connected to personally identifiable information with the explicit consent of the user, and yet secondary purposes have created databases of mobile ad IDs of the scale of billions tied to precise personal information. It made us want to ask these people, what was the consent? What was the circumstances of this consent, and how do you feel about it? And so since we had been given millions of rows of emails that we were able to get the emails for these people, we did a study where we emailed them and asked them their feelings. So we asked users, for instance, are they surprised that their email is being sold by data brokers? Not at all was the median response. Are they concerned? The median agreed that they were concerned. We asked them if they thought it was inappropriate, and beyond the 75th percentile, it was very inappropriate. We asked them, how do they feel about ads using personal information for targeting? Again, this is something that companies will say is that consumers like behavioral targeting. They like our products. You know, cigarettes are good for you. 77% are opposed or strongly opposed to using personal information for ad targeting. 3% were in favor or strongly in favor. Of the 377 participants, 94% preferred their email not be sold, 5% weren't sure, and 1% were in favor of it being sold. 1 to 3% had heard of the brokers selling their data. Often brokers say, well, users can tell us and we'll delete their data. Well, 1% to 3% had heard of the company that was selling it. And we included Experian, the credit reporting agency, as a sort of control to make sure a more well-known company had been heard of, so they were answering that correctly. We had some fake companies, and they matched at the same rate as the actual company that was selling their email address, about 1% to 3%. And 3 total people recalled consent, so less than 1% had a recollection of consent. For use of the advertising ID on Android, 43% had never seen the screen with the advertising ID on it and the ability to reset their advertising ID. 43% had just never even seen it. 13% had, at some point, a recollection of resetting their advertising ID. We asked them at the end, we told them, you can send a deletion request to this data broker that your data was found on. We asked them, do you plan to send a deletion request? And 77% on that 5-point scale definitely would send a deletion request. 10% said they wouldn't. If they said they wouldn't, we asked them why. And the responses were around learned helplessness, that it won't make a difference, someone else will get the data, it'll just keep happening, and there's no guarantee that they'll even delete it. Whatever notion or definition of consent results in these kinds of outcomes is a very twisted notion of consent. I would like to thank the people I worked on this with, so Serge Eagleman, who helped with the data broker, getting the data from the data broker, and also the user study. Ken Bamberger is a law scholar who's going to help us with the legal review side of things. We're going to make a law review article over this. Then students, Tin at the University of Calgary, who is doing the browser plugin to find emails as you're tracking around on the web. And then 2 talented undergrads. I had Angelina, who worked on the rainbow tables and the different formats of emails, Joshua, who is scoping out the data broker economy, and Laurel is a law student at Berkeley who found those case law examples of claims being made about anonymity of hashed emails and so on in the real world. I also want to thank Troy Hunt and Bruce Schneier for personal conversations, and then the team of MD5 crackers who basically overnight matched the success that I had taken months of work doing with a handful of GPUs. And with that, I'm happy to take questions.